Today we're going to be talking about function composition. Most of you should probably have heard of this. It's not currently taught in 105, but you've probably had it mentioned back in high school or something. But I would still suggest paying attention so you get to understand it slightly better. So when we're talking about composing functions, it's taking two functions and writing them as f of g of x. What does that actually mean? That basically just means f of g of x, where instead of evaluating a function for a value or evaluating a function for an expression, you're evaluating a function for another function. So it's basically just the next progression. So in this situation, if you're writing this, as I said before, for the evaluating expressions or evaluating functions, you'll want to write parentheses wherever there was an x from the first function. So in this situation, the f, or you can call it the outer function. After you do that, you write in the inner function or second function. So we end up with x divided by x minus 2 squared plus 3 times x divided by x minus 2 minus 4. When you have a squared outside of parentheses, you are only able to bring it onto each individual item if they're getting multiplied together or divided. So for this first part, we can bring the squared onto the x on the top and the x minus 2 on the bottom. You cannot do x squared minus 4. That does not work. So when you bring x minus 2 squared, you get x squared minus 4x plus 4 in our denominator. On the second term, the 3 multiplies by the numerator, not the denominator, because you can view it as 3 divided by 1, which the 3 multiplies the top, the 1 multiplies the bottom, so it doesn't do anything. Now, this is not a very nice form for our equation. So it's helpful to simplify it a little bit. So we need to get a common denominator. Well, the biggest denominator is x minus 2 quantity squared. Our second denominator has x minus 2, and our last one doesn't even have a denominator. So our common denominator will be x minus 2 squared, or x squared minus 4x plus 4 in its expanded form. So we multiply our second term by x minus 2 over x minus 2, and our last term by x squared minus 4x plus 4 divided by x squared minus 4x plus 4, which will give us the situation here. Note how on the last term, since it is minus 4 times that fraction, you have to do minus and then do parentheses for that entire thing, because that will change some of the signs. And then with simplification, we get to this term here, which is actually not fully simplified, because the first term will actually cancel out with each other. All right, so there's that. Let's go ahead and look at the domain of composing functions. So let's stick with the same two functions, but let's look at the steps for it. So you will need to start with the domain of the second function or the inner function. So whatever is inside the parentheses or comes after the circle. And then you have to look what is excluded in the first function, so before the circle or outside the parentheses, and set it equal to the second function. This sounds a little confusing, so let's take a look at this example of g of f. This is the opposite of what we had before, so pay attention. So we look at our second function, which is f, and start with the domain of that, which is negative infinity to infinity. Good thing to start with. Now, 2 is not included in our domain for g of x, which is our first function or the outer function. So we need to set 2 equal to our function f of x, which gives us x squared plus 3x minus 4 equals 2. And then we need to solve for x, which, putting it to Desmos using graphic calculator, any method, you get x equals negative 4.372 and x equals 1.372. So those values will set f of x equal to 2, but f of x is being put into g, and we can't have 2 put into G. So that means those values get excluded. So our domain becomes this here, -infinity to -4.372, union -4.372 to 1.372, union 1.372 to infinity. Alright, so that was the nitty-gritty detail about it. Let's go ahead and take a look at the actual Desmos put out for it. You can see for g of x, we have a vertical asymptote, and f of x is just a standard parabola. Let's go ahead and take a look at what g divided by f of x is. Well, that looks pretty ugly. Has 2 vertical asymptotes on it, which if you remember, we excluded 2 points. But if you see, they're roughly at this point here, which is where our function f of x is equal to 2. Pretty useful looking at. And zeros, well, the zeros happen to be the same place as f of x. We can discuss that why that happens later. Let's go ahead and take a look at f of x, or f of g of x. Now that one is a really funky shape. Goes down, comes immediately back up. So, that's not a 0 for g of x. But it's not really a 0 for the other items either. So, you have to be careful. We do have some nice intersection points that do show a little bit of information. But you cannot make general ideas stick just by looking at it. So, that's going to be it for this video. Hopefully you enjoyed it, and it was informative.